All right. You got your notes, please, if you haven't already. Our objective for the first 15 minutes, sorry, is this thingy. I'll read it off. 2x to the fourth minus 13x to the third plus 12x squared plus 17x minus 10. Your job is to solve this, find all solutions, then factor it, then sketch a graph. First, does anybody see any methods of factoring that work on this thing? No. How many terms does it have, first of all? 5. There's nothing that we know of that works with 5 terms except GCF, and there isn't a GCF, so too bad it's so sad. So, how are you supposed to solve this thing? There's only one method we've ever covered at this point. Start guessing. Yeah, this sounds kind of scary, but start guessing. Guessing what? What are we trying to guess at? We're trying to find the what's. Yeah.
Is it the roots or solution?
Yeah, roots, solution, same difference. Yeah, guessing at roots. But right now, sky's the limit. Could be x equals 100, x equals negative 3.8. Are there any limits to our guesses? First of all, how many roots am I looking for? Tell me, yeah.
4.
4, how do you know that?
Because it's the degree.
Yeah, the number of roots is 4, because that's the degree. Anybody remember the name of the theorem that says that? Yeah. The fundamental theorem of algebra. The fundamental theorem of algebra says that the number of roots in any polynomial is equal to its degree. Okay, so we know we're going to have 4 roots, so once we find 4, stop guessing. That's at least somewhat helpful. Are there any limits on where I guess? Like, would I try x equals 40? Would I try x equals negative 25? Yeah.
It has to be within the last term.
Yes.
Positive and negative.
Correct. So in other words, it's got to be between what and what in this case?
Negative 10 and 10.
Right. So in other words, the roots have to be between negative 10 and 10. These are the x's that we're looking for. All the values of x that make the thing work equal to 0 should be between negative 10 and 10. It does include negative 10 and it does include 10. Are those guaranteed? No. But you never have to go past those. So that helps. What else? Can anybody give me a list of all possible fraction roots, also called rational roots? This is called the rational root theorem. In other words, the list of all possible quote-unquote nice roots. And by nice, I mean rational. How do you get it? It's a big fraction with a bunch of independent numbers. Check your notes yesterday. Let me see it. Yeah.
We do the factors of the last coefficient over the factors of the first coefficient.
Yeah. Factors of the last. Coefficient. I'm going to abbreviate there. Over factors of the first coefficient. That will give you a list of fractions to try. And by the way, that is the list you will try. Anything that's not on this list, you are not on to guess. If you guess every single one of them and none of them work, you're off the hook. Can somebody do that for me? And by the way, factors do include positive and negative. I'm going to put plus minus. Can somebody help me out with the factors of the last? Josh.
So the
And you can put them in pairs if you want.
2 and 5.
2 and 5. So let's go 1 and 10, and then
2 and 5.
2 and 5, anything else?
Or maybe -1.
Yeah, and that'll cover that.
Oh, gotcha.
So it looks good. What about the bottom? Mary Clark. Plus and minus what? So the factors of the last coefficient were all the factors of 10. I put them up on top. What do I put on the bottom?
Oh, that's just the first.
Yeah, factors of the first. And there aren't very many.
2.
1 and 2. And positive 1, positive 2. Positive 1, positive 2, negative 1, negative 2. Can somebody break these apart and list all of the possible fractions you could get? Just mixing and matching these. And boil them down if you can. Let me see. Kitty, help me out. Give me the first fraction. 1 over 1? Negative 1 over 1. Good. 10 over 1? Negative 10 over 1. Go ahead and boil these down while we're at it. 1, negative 1, 10, negative 10. Correct. What are those really? Okay, keep going. Uh-huh. So we've got 5, negative 5. Does anybody notice we have some more? Those are 8 options, but there are actually 8 more. Everybody see them? There may be duplicates in there. So,
We have to put them all over.
these are the same thing. And then what?
Put them all over 2.
Yeah. 1 over 2. Negative 1 over 2. 10 over 2. Negative 10 over 2. Now again, there may be some duplicates when we're done. 2 over 2. Negative 2 over 2. The duplicates we'll throw away. And then 5 over 2. Negative 5 over 2. Quick question. How many total fractions? Counting the duplicates, how many total?
16.
16. Would there be any way to know that ahead of time? Here's a hint. Ignore the plus minus. How many possible mixes and matches can you do with 4 on top and 2 on the bottom?
8.
8. So 4 of them over 1 and 4 of them over 2. Is there a quick way to get that number?
Yeah, you multiply it.
Yeah, 4 times 2. That would give you 8. And then the plus minus gives you 16. So that'll tell you ahead of time there's 16 possible fractions. So here are the first 8 after you reduce them. And then let's go through these. Some of these are duplicates, so throw them out as needed. Mary, help me out here. Any of these duplicates?
5.
Yeah, this is 5, because we already have that, and then
-5.
-5 scratched off, okay?
And then 1 and -1.
Correct. 1 and -1 are scratched off as well. So it looks like we have 4 new candidates. Can somebody tell me the 3 things that we listed as far as methods for solving these yesterday? What's the very first one? We kind of covered it already. But look at your notes yesterday. What's the first thing we did today, and what's the third thing we do in general? Yeah.
The degree equals the number of roots.
Right. I have to find out how many roots to look for. The degree is the number of roots, fundamental theorem of algebra. What's the second thing you look for? Or the second thing you do? Go.
The last constant term is the maximum range.
Yeah, the last constant term is the maximum range, plus minus. What do we do after that? What was the third thing we did today and yesterday? Go.
The rational root theorem.
The rational root theorem. It'll list all the possible fraction roots. Factors of the last over factors of the first. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8. We have 12 unique solutions to try. We don't know if, only 4 of these are going to work. And I'm not even sure all 4 of them are in here. There are some things that actually have garbage roots, like radical 5 or something like that. You notice there are no radicals in here? There are no i's in here. Basically, if there are any weird solutions in this, they're invisible to us. At least invisible to this thing. The rational root theorem can see nice roots. It cannot see the icky roots. If there are icky roots, you're mostly off the hook on those. So, it's guessing time. I will give you one last hint though. You know those 3 things we gave you yesterday? One last thing before we start. Whoops, it's not the marker I want to use. Hint. Let's see. If the lead coefficient is not 1, if the lead coefficient is not 1, it's almost guaranteed. That we have a fraction root. With x equals some number over a, where a is the height multiplier. Or a factor. Basically, since the lead number is 2, I can almost guarantee you that one of the roots is going to be something over 2. In other words, one of these 4 on the bottom is probably in there. There are rare exceptions. But basically, if there's a 2 here, I'm going to expect at least one of the roots being something over 2. If there had been a root number 3 here, I would have expected something over 3. If this had been 6, I could have had 1 over 6, or 1 over 3, or 1 over 2, or 1 over 1. So, let's start guessing. Who's feeling lucky? Today we're actually going to find a few extra tricks to narrow down our list. These are the most basic ones. These are the fastest ones to use. There are other ones that are slower to use, but they're pretty powerful. It's kind of like the quadratic formula. It takes a long time, and complete the square. It takes a long time, but it's pretty powerful. Who wants to try it? And then talk me through it. How do you guess at roots? Like, how do you test to see if a root is actually working or not? Yeah.
You just plug it in.
You can plug it in, and then hope you get an answer of what?
0.
0. If you get an answer of 0, that means you succeeded. Because if you set this equal to 0, that means you're solving. They ask you to solve, so I'm going to set it equal to 0. Speaking of which, let's do that. There is another way other than plugging it in. Pretty much, yeah. Oh, sorry, never mind. Plugging it in, does anyone remember something called the remainder theorem? What happens when you plug a number into a function? It gives you the exact same thing. It gives you the what? If you plug, let's just say I plug the number 10 into this thing. That will give me the what? Yeah, the remainder. If you divide this thing by x minus 10, the remainder is the same as if you plugged in 10. If I divide this whole mess by x minus 3, plugging in a 3 will give me the remainder of that. If I divide by x plus 5, plugging in a negative 5 will give me the remainder of that. Why should I care? Well, if you plug something in, the answer is the remainder. So if the remainder is 0, that's great. If it's not 0, then you got to try again. But there is another way to get remainders. Yeah.
Synthetic division.
Synthetic division. Or if you're into self-abuse, long division. Right. Teach your own. Can somebody suggest a number to guess? Let's see how lucky you are. By the way, this is me personally, I usually do not guess the biggest and grossest number first. Why? You could. I start small. Why? Because I'm a wimp. My old high school math teacher used to say mathematicians are lazy, but they're a good kind of lazy. They only avoid unnecessary work, which is not immoral, by the way. It's clever. What would you suggest?
5.
5? Okay, wow, you're ambitious. All right, let's try it. Give me the numbers for synthetic division.
2,
Uh-huh,
negative 13,
uh-huh.
12, 17, negative 10.
Okay, so skip a line, draw a line. Let's run. Go for it.
2,
Yeah, add, then multiply.
10,
Okay,
negative 3,
okay,
negative 15,
okay,
negative 3,
okay.
negative 15, negative 2,
Uh,
positive 2,
2.
10.
Did you know that we? First of all, congratulations, you just found a root. X equals 5. One bonus of synthetic division. One bonus of like, okay. Next time I play the lottery, I'm asking you. But, I don't play very often. But the next time, let me start that over. I'm still using the stupid metaphor. One advantage to doing synthetic division is not only does it tell you whether it's right or wrong, but if it is right, can somebody tell me what this stuff is? Can you translate it for me? Very quick. This used to be 2x to the 4th.
Just 2,
Yes, plus
3x squared,
negative 3x squared plus
and 3
x plus 2. That's the remaining thing. You just ripped one of the roots out. How many roots are left? 3. There are 3 roots in here. I would suggest checking to see if you can factor it or not. See if it, and this one, maybe factor by grouping would work. I gave you a trick for that yesterday. Somebody think that'll factor by grouping? Anybody remember the trick? The first pair and the second pair have to be proportional. So like 2 is to 3 as 4 is to 6, or something like that. Are these proportional? 2 is to negative 3 as negative 3 is to 2. Are those proportional? What do you think? Go ahead, be daring.
No.
You are correct. No. If it were 2, negative 3, 2, negative 3, I would have said winner, winner, chicken dinner. But here, no. 2 is to negative 3 as negative 3 would be to, oh, that'd be horrible. It'd be like 2 is to negative 3 as 20 is to negative 30. That would have worked. Or something like that. So they have to be exactly proportional. They can't be backwards. In other words, factor by grouping will fail us. We gotta keep guessing. However, bonus. Do you see this last number here? You remember the last number up here? That means the roots are all between what and what? What's that? Negative 10 and 10. Guess where they are now? They're between negative 2 and 2. That's a huge bonus. By pulling out x equals 5, Mr. Wizard, you just pulled out a lot of our work. I'm going to throw away 10, I'm going to throw away negative 10, I'm going to throw away 5, I'm going to throw away negative 5. All the other ones are still fair. Oh, actually, the 5 over 2 and the negative 5 over 2 are too big. That's 2.5 and negative 2.5. They're out of our bounds now. Phew. So we don't have a lot to guess. 1, negative 1, 2, negative 2, 1/2, negative 1/2. We have 6 possible guesses left, and that's it. That, by the way, is good news. Yeah. So, who wants to do another guess? Becca, try your luck. Spin the wheel. See if you win a fortune. Okay. Good.
negative 2.
-2? Okay, let's try it. Add. Just ignore the x.
2.
2. Multiply.
Negative 4.
-4. Add.
Negative 7.
Multiply.
Is it negative 2?
It's -2 and -7.
14.
14. Add. And sorry, the thing's away.
11.
11. Multiply.
Negative 22.
Is this going to work?
No.
Unfortunately, no. We get I should actually do it. I'm getting lazy. -20. So let's reset it. we had 2, -3, -3, 2. So I'm gonna try a different one. So, -2 didn't work. Good one to try. Nick, try your luck.
2.
2, all right. Box number of 2. Try it.
2.
Add 2, multiply.
4.
Add
-1. No, 1.
1, good save.
2.
2,
1. And -1.
-1.
-2. 0.
Lucky. You just found another root. X equals 2. Look at the last number. All your remaining roots are between what and what?
-1 and 1.
-1 and 1. You can throw out, well, we already did positive 2, I guess. I guess that didn't help us a lot because we already knew that, but okay. All of our roots are between -1 and 1. So it could be 1, -1, 1/2, -1/2. And remember our hint. One of the solutions is probably a fraction. So one of these two is almost guaranteed to work. So okay, by the way, can you translate this for me? Let me see, same. What is this? This used to be 2x cubed.
It's 2x squared
Yep.
plus 1x
Plus
plus -1.
-1. This has a degree of what, Austin?
A degree of 2.
Degree of 2. What do we call something with a degree of 2?
Polynomial.
Definitely polynomial. A degree of 2 has a special name.
Quadratic.
Quadratic. Now that's interesting, because I'm going to get rid of this thing because it didn't work. If it's a quadratic, if it's that small, you might be able to solve it by hand. There are several methods. As a matter of fact, in our class we covered there are 4 different methods we solve quadratics with. Algebra if you're lucky, factoring in zero product property if you're lucky, completing the square, and good old-fashioned quadratic formula. Anybody want to take a hack at this? Does this factor? Yes, with a slight quarter background. Yeah, what do you think?
No, would be no.
We know? Maybe. You might be right. How do we solve this guaranteed? Because you're right, it might not factor.
Quadratic.
Quadratic formula is pretty much guaranteed. Complete the square is almost guaranteed too. Actually, it's guaranteed, but it's long. Can somebody set up the quadratic formula for me? Let me see. Chili. Use the quadratic formula on this thing. Let's see if we can get it.
So it's, do you want me to see what the formula is first?
Sure.
Okay, quadratic formula is negative b plus
Oh.
minus square root of b squared minus 4ac all over 2a.
Yeah, negative b plus or minus square root of b squared minus 4ac all divided by 2a. Let's go for it. So negative 1.
Negative 1
Negative 1.
plus or minus the square root of 1 squared minus 4 times 2 minus times negative 1
Times negative 1.
divided by 2 times
2
2.
times 2. Good. Let's try this thing. Nick, take over.
That'd be
Simplify.
-1 plus minus square root of 1. 1 minus 8 plus 8.
1 plus 8, good. 1 minus negative 8, all over 4. What is 1 plus 8? Last time I checked. What's radical 9?
3.
3. X equals negative 1 plus or minus 3 all over 4. What 2 solutions are we going to get there? Go ahead, keep going.
We're gonna get -1 plus 3.
What is that?
2.
2 over.
4.
What is that?
2. 1.
1/2, good save. And then X equals what?
-1 minus 3.
Which is?
4. Negative 4.
Negative 4 over,
4.
which is?
Negative 1.
You have just found your last 2 solutions, and you're done solving. Congratulations. And you notice 1/2 and negative 1, they were on our list. 1 was good, and negative 1/2 is good. The 1/2 got scratched off, the negative 1 got scratched off. See how that worked? In other words, when the thing gets small enough, you don't have to guess anymore. You can factor, or you can use quadratic formula if it's a quadratic. or what have you, or if you like factor. This thing actually does factor. You have to use magic pair though. Questions so far? So again, step one, we started guessing. It's kind of like, don't do this in real life. Let's say it's really super duper foggy. You've got a gun, you're hunting ducks, and you hear quack, 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 quack up there in the fog. Blam, 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 hoping you're going to hit a duck. By the way, in real life, this is what's called stupid. You might hit a plane for all you know, so don't do this. But we're just shooting in the dark. Well, we do know there are limits to our guesses. The limits come in really handy. In this one, don't guess bigger or smaller than 10 or negative 10. And don't go outside of this list. I would never have guessed x equals 7. I would never guess x equals 3. I would never guess x equals 4, because it's not on the list. This eliminated a lot. Does that make sense of that? All right. This says solve. You're done with that. So we've got, actually, can somebody list off the 4 solutions, like in order that we found them? Randy, what do we get, like total?
Oh, in order that we found them?
Like all, it doesn't matter what order.
Oh,
A half,
5,
5, 2,
2,
and negative 1. Correct. Those are solutions. Now, they also asked us to factor this monster. Is that okay with the rational root theorem? Or I need to erase it for space. I hope that was okay. How do you factor this? Now we already decided we can't factor this by any normal method we knew. It's got 5 terms and it's too big. But we already solved it. So when they say factor, I would like to what I call reverse engineer. You see the x equals 1/2? Can somebody tell me what parentheses that came from? Go.
X minus 1/2.
Exactly. This is f of x equals x minus 1/2. Let me see. Sam, what's the next one?
X minus
X minus what?
5.
5, correct. Give me one more.
X minus 2.
X minus 2, give me the last one then, because they're cheap. X plus 1, why plus?
Because it's in half.
Yeah, it came from negative 1. So if you see how I went backwards and found those? It's the zero product property backwards. I would just argue there's one last thing. Can somebody tell me the height multiplier? Look at the original problem and it'll tell you pretty quickly. Becca, what's the original height multiplier in this monster? It should be staring at you. The height multiplier is the very first coefficient. If that helps. Yeah. You see this 2 here? That is A. And what I'd like you to do is copy and paste that in front. You have successfully factored a monster degree 4 polynomial. Questions? Then sketch a graph. Oh dear. How? Is there anything you can tell me about where points would be on this thing? Yeah.
You know the x-intercept?
We know the x-intercepts. List them.
1/2.
1/2? Oh man, a lot. How do I, here, I'll just do these 1, 2, 3, 4, 5. And then I'll do a half here. By the way, if it's not a whole number, please label it. Okay.
-1.
-1. Okay, that looks good. I'm going to label them all, just to be safe.
2
2
and 5.
and 5. Can somebody tell me anything else about this thing? Josh. What basic shape is this thing? First of all, what degree is it?
It's 4.
Degree 4. Is it a positive degree 4 or a negative degree 4?
Positive.
Positive. The height multiplier controls almost everything on this problem. It's a positive degree 4. Can you tell me what shape that is? What do you think? It's a W shape, correct. It tries to hit the x-axis 4 times, and it ends going up. Because remember, if it's a positive, it'll end going up. We don't know where it starts necessarily, but we know where it ends. And we know it tries to hit the x-axis 4 times. So this is going to be kind of a W. Can somebody guide me on how to sketch this thing? Oh, speaking of which, can somebody tell me where the y-intercept is? If you know where to look, it's relatively easy. I would not look here. Anybody see it? Maybe.
-10.
It's -10. Y-intercept is when x is 0. So 0, 0, 0, 0, -10. If you plug in x equals 0, all the other terms die except 10. So -10 rather. So it's going to hit here. Can somebody guide me as to what this shape should do? Where should I be on the far left? Should I be above or below? Okay, above. It's got to be above. And it's going to come down. When it hits -1, is it going to go through, bounce, or swerve? Go through. Why do you say that? You're right. Why did it go straight through? Why didn't it bounce? Yeah, what's it called? What kind of a root? You have 2 roots at the same location. That's a double root. That would have bounced. Like if there had been an x minus 1, x minus 1, or sorry, x plus 1, x plus 1. If there had been a double root, it would have bounced. This one is a single root. It goes straight through. And it's got to go through 0. When it goes up through one hand, it's got to go up to hit this again. Blaze, is it going to bounce, go straight through, or swerve?
Straight through.
Straight through. Pow. Now notice, this is about 1.5 spaces. This is about 1.5 spaces. So I'll bet you that the distance here and the distance here are pretty close to equal. Hey, darn it. Sorry, I'm running over my number. Coming back down. Mary Claire, is it going to go straight through, bounce, or swerve? Straight through, correct. And there's a 3 space, I don't have much room here, but it's going to go down even farther, and then I'll spoil the surprise. It goes straight through. This goes, sorry it was such a mess. But that's a reasonable sketch, albeit messy, of the graph.
So, when you're plugging numbers in to like try and guess what it is, how would you know if you found like a double root? Like what if it was 2 x plus 2?
Excellent question. How much time do I have? I'll tell you that tomorrow. I'll have to keep you in suspense. I will tell you right now, there are no double roots in this assignment. There will be on the assignment after. No problem. There are 4 problems on this thing total. These 4 will be due tomorrow. No problem. And I did not make them really huge. I think they're all degree 3. Some of them might factor by grouping, some of them might not. Don't count on factor by grouping. If you find one, rejoice and be glad. Correct. Once it gets small enough, you can factor in all way through. Yep. Okay, for the people watching at home, this is homework, I don't know if you can see it, homework 2B-2. I will email this to you. Use this technique. All of them are degree 3, I think. Yeah. They might factor by grouping, they might not. I would look first, because if it factors by grouping, your problem gets much, much faster. You don't even have to start guessing. Okay? And there are 4 problems I would like this due tomorrow. Let me put this up on the board. You obviously won't see me do this. Oh, did I already do it? No. 2B-2. What is today? Well, no, it's 2B-2. Okay. Sorry. That's supposed to be 2B-2 in the first place. And that should be it. So, I think we're good to go. Any last questions? Otherwise, you have about 15 minutes. Go ahead and start hacking and slashing. People watching at home, this is my hand waving goodbye. Talk to you later.